this is going to be a quick lesson on something called a design pattern, specifically about the state machine design pattern, which is going to be really relevant for us when we're doing our animations. But what is a design pattern? Well, a design pattern is a reusable general solution to a commonly occurring problem in software design. They're inspired by patterns in real-life architecture, and they apply to non-game software development as well. Because a design pattern is reusable and in general, you can think of it almost like a guideline from a guidebook. It generally can be used, and then you just have to specify and build it out for your specific project. Through years of development, developers have figured out solutions to commonly occurring problems. And when they kind of get used enough and they get structured a certain way, they eventually evolve into something called a design pattern. Now, these design patterns are not hard set in code. They are not a function that you call when writing your code. Instead, it's a design philosophy, I guess you'd say, and you build your things around it. Because these are so common though, things like the Unreal Engine will build in functionality. So why would you use a design pattern? Well, it's a common practical solution. They address common challenges with solutions that have worked in the past. You don't need to reinvent the wheel. You also get a common vocabulary for architectural concepts. We're going to learn about a state machine. And a state machine for animation is the same concept as a state machine that's used for app design, to tell you what screen on an app you're on. They facilitate easier changes and flexibility so that they make for better development. And they're really adaptable. The core principles remain timeless, even if how they're applied is a little bit different. In the advent of AI coding, vibe coding, and development, one aspect that is not really well done are these design patterns, in the sense of it'll generate some code that will solve a problem, but it doesn't solve it in a way that will scale or that will really fit with other things. So it's a concept in software architecture that you need to understand. Even if the day-to-day code that you write is created by AI, you have to know how it all fits together. Design patterns are the way to get those things to fit together. Now, there are some common game development design patterns. First one being a state machine. Then you have singletons, which we shouldn't ever really use. It's actually kind of a no-no, but we should talk about them. The observer pattern, and then pooling pattern. We'll end up seeing observer and pooling a little bit later on. But for right now, let's talk about state machines. But first, this is the best book on the subject, Game Programming Patterns. I would suggest that if you're looking to learn anything about design patterns, even if you're not a game programmer or you're doing this as a hobby, I highly recommend this book because it is genuinely one of the most approachable, clear, and generally entertaining way of learning about this stuff. It also is the single best back cover of all books ever, in my opinion. The author of this puppy. So, the state machine design pattern. What is that? A scenario. Let's say your main character for a game is a robot. The robot can move left and right, jump, climb walls, and attack. You're in the process of writing the code for it to be able to do these things. In this game, you shouldn't be able to attack while jumping, though. If you're jumping, the designers don't want the character to be able to attack. You also shouldn't be able to attack while climbing a wall. If you're using your hands to stick to a wall, you kind of can't punch something, right? How do we easily define the behavior for what it can or can't do at certain times? Well, we use the state machine pattern. A state machine pattern is a fixed set of states that an object can be in. A state machine can only ever be in one state at a given time. You can only ever be jumping or climbing or attacking. You can't do multiple things. This will let you transition between states based on inputs or events. So you define what a character can do in a certain state based off of external variables like input or movement or getting attacked or getting hit or whatever. You can transition that character into these other states. So we have a robot character that gets states for idle, walking, jumping, climbing, and attacking. You can then transition between these states, and in those states, you define what you can do. So when you're idle, if your character is in the idle state, it should trigger the idle animation, and you should be able to transition to attack or jump or walk or climb. Meanwhile, while you're jumping, we can say, hey, you can transition to fall and idle or to climb, but you can't transition from jump to attack because that's what we don't want our character to be able to do. So if your robot is in idle state, you can transition to walk, jump, or attack based off of player input, but you can't climb. If you're idle, you're standing still, you can't climb on anything. There's nothing to climb on. So you can dictate what states you can go to. Then let's say that the player pressed the jump button. Your robot can transition to the jump state. It can climb or idle, but it can't go from jump to walk or jump to attack. Now, this is an oversimplification. However, the concept of a state machine really boils down to what you can or can't do. All right, so let's go ahead and create a state machine. Now, back in Unreal in my animation blueprint, I'm going to go to the anagraph. I'll delete these animations there. I don't need those. Instead, I'm going to right click. I'm going to create a state machine. Add new state machine. I'll call this locomotion. And I'll connect this to my output. So I've created a state machine, but I need to actually define what the states are. So I'm going to open up locomotion. And in my locomotion state machine, I have one node, the output. So I'm going to go ahead and drag from here, and I'm going to add in a new animation state. And I'll call it idle. So I now have an idle state. I'll open that up, and I can give it the animation I want to play. So I need to add idle, so I'll right click and I'll search for idle. Play idle. Now with the animation, the play idle animation here, I want to make sure that this is set to loop. Well, actually, you know what? Let's think of it this way. With that animation selected, I can change the sequence if I wanted to. I can change the play rate, the start position, or loop animation. Now this is a looping animation where the last frame and the first frame loop together. So it plays the same thing over and over again. So let's go and connect that to my output. Then up here, I have this bar where I can go to my different parts of my anagraph. All right, so I'm going to go back all the way out to locomotion here, compile and save, go back to my game and press play. It is now playing the idle animation. All right, well, let's open up our locomotion here. And from idle, I'm going to drag out here and I'm going to add an animation state. And I'll call this state running. I'll open this up and I'm going to right click and I'll do running, play run, connect that there, make sure loop is on, and I'll go back up here to that locomotion, to my state machine. So I now have two states. I have an idle state and a running state. The states themselves are pretty simple. You don't have all that much involved there in each one of them, but I still want to be able to transition between them. Well, here we have a transition rule. So this is a check to see, well, should we go transition from idle to running? Let's open that up and let's tell it what the rule should be. We should go from idle to running if is moving. So get is moving. And so if is moving is true, we want to transition from idle to running. Let's compile and save, go back and press play. So I'm starting idle, and if I move, I'm playing the running animation. It doesn't stop though. Well, if I go back to my animation blueprint, back to my state machine, the arrows dictate directions we can go. We can go from idle to running, but we need to be able to go from running back to idle. Well, I can actually just go from running, drag, click and drag to idle there. And now we can define the rule for how to go from running to idle. So I'll open that up. Well, to go from running to idle, I want to check to see if is moving. So I'll get is moving. I want it to be where we can transition if it is not true. So I'll drag from here. I'll search for not. And I want to grab this not Boolean. So if it is not true, then we can transition from running back to idle. So compile and save. Let's test it out. So I'm running, back to idle, running, back to idle. There we go. So now we have one animation going. Next up, we need to get our jump and other states working. So that's going to be it for this one. Thanks.